Hello viewers, Wagadaruna taking you through this tutorial for A-Level Applied Mathematics. And this video we're going to go through the marking guide for Senior 5 Math Paper 2 end of Term 3 for the year 2023. So this video is suitable for students in both Senior 5 and Senior 6 offering Principal Mathematics as part of their combination. So this end of term, the paper was a standard paper. It included the 8 questions in section A, each carrying 5 marks, and also the 8 questions in section B, each carrying 12 marks. And the student was supposed to answer all the questions in section A and any 5 in section B. So we shall begin with the questions of section A. Question 1 was from probability, the topic of probability theory, and says two independent events R and S are such that probability of R is 3 over 4 and probability of S is equal to probability of S complement intersection R complement. Find part A the probability of S and part B the probability of S complement intersection R. So the key word here is this word independent events. So what we are going to do, we shall start with what is given. This is equal to this. But for independent events, if R and S are independent, it means that even their complements are also independent. So you could use that logic, or you use the logic of contingency table or set theory. Whatever is okay. So here we shall look at two alternatives. One, by using that knowledge that if R and S are independent, then their complements are also independent. So that means that even these ones are independent, therefore probability of S complement intersection R is equal to probability of S complement times probability of R complement. Then remember that S complement is the same as 1 minus probability of S. R complement is the same as 1 minus probability of R. The good thing, I know the probability of R. So I'll come and substitute for the probability of R and I remain with PS as the only unknown. So my aim is to look for a way of making it this subject. One is open brackets. So that this is a quarter. So a quarter times 1 is a quarter. A quarter times PS is a quarter PS. Then you collect like terms, take this one this side, 1 plus a quarter is 5 over 4, PS equal to a quarter. Then here, this can cancel, you remain with PS as 1 over 5. That was part A. Then part B, they wanted probability of S complement intersection R. But before we proceed, let me first talk about these books which are vital for your level. So if you are just joining Senior 5 or you are joining Senior 6, these books are of good help if you have not yet got them. There is Math 1, Math 2, Topical Question Bank, and Termly past papers. So those who buy this year, your NEB for 2023 will also be included. Then for physics, there is also Physics 1, Physics 2, Topical Question Bank, and its solutions. So those who will buy this year, the year 2023 will also be included. So I encourage you to call on this number so that you can be directed where to get them at a cheaper price. Otherwise, the books are available in bookshops, but at a little higher price. So part B, they wanted this. We are still using the logic for independent events, meaning this is the same as this times that. Then you substitute, this is the same as this, substitute for this, then you'll use a calculator to come up with this as the answer. Alternatively, one could use a contiguous table. by saying that from De Morgan's law, this is the same as this. When the sign here changes, even the complement goes out. Then you expand this union to give you this. Then you can now substitute for PR here and here. You still have PS as the only unknown. So look for a way of making it the subject. So this time minus this is 1 minus 3/4 gives you positive 1/4. And this positive 1/4 with this gives you negative that. Then this positive 3/4 with this gives you negative 3/4. Then again, collect like terms, take this on this side to give you this, and this with this gives you 1/4. This cancels with this, and PS is 1/5. So any of the alternative is okay. Still part B, you could use contiguous table by saying this is the same as PR minus intersection of S and R. Then substitute and get the same answer. So that's how the 5 marks would be got. 3 part A, 2 part B. Question 2 was from the topic of vertical motion under gravity. And it says, a stone is dropped from the top of a tower. Okay. 1 second later, another stone is thrown vertically downwards. Note this word, downwards. From the same point with a velocity of 14 meters per second. Okay. If they hit the ground together, find the height of the tower. So there was a tower. One, you just drop a stone, it means that the initial velocity is 0. Another one, you just throw it with a certain velocity. They move. This one is, if this one takes t seconds, this will take less by 1, so it will be t minus 1. Or if you say that this one takes t seconds, this should take more, so it will be t plus 2. So in short, the particle which was thrown later will take less time. So for the first stone, initial speed is 0, initial velocity is 0, time is t, and height, displacement moved is the height of the tower. Therefore, from the second equation of motion, I'll substitute and simplify to get equation 1. For the second stone, initial velocity is 14, time is less by 1, and displacement is the same. So still from the second equation of motion, I'll substitute for S, for U, for T, here and here, then for G. Then you substitute. Remember, H is equal to this. So where there is H, come and put there that. And also expand this to give you this. Then also this one gives you 4.9. Then this one, expanding it, gives you this. Expand further, open this bracket to come up with that. Then you collect like terms, realize that this and this cancels. Okay, then this minus this. Then also it gives what? It gives 4.2t. Then negative 14 plus 4.9 gives you negative 9.1. Make t the subject, and that will be the value of t. But they asked for the height, so go back to equation 1, substitute for t, and get the value of h. And that will be the answer. And that's how the 5 marks would be got. Question 3. The random variable capital X has the following probability distribution. Find the value of the constant k and the expectation of x. So 1 is to tabulate because it is discrete. So come the column of x, you'll put there the values given, 1, 2, 3, 4, 5, 6. Then the probabilities, you write the probabilities with unknowns. Add them. The whole of this gives you this. Now that I know this total, I can remember that total probability is equal to 1. Therefore, substitute and equal to 1, which gives you k as 1 over 32. Then I'll draw another column of probability, by this time when I've substituted for k, to give you that. Then I can now multiply to get xpx. This with this, 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 then the total will be that. So this total we have got will be the expectation they wanted. And that's how the 5 marks will be got. Question 4 is vector mechanics and says if forces F1, F2, and F3, where A and B are constants, acting on a particle of mass 2 kilograms, then they said given that the acceleration produced is this, find the values of A and B. So we shall come and remember that from Newton's second law, F is equal to ma. So but that F is the resultant force. So this, and this will be equal to ma. So come and substitute for F1, F2, F3, m, and acceleration. So when I simplify this with this, 16, this with this, 6. This here gives 20, this here gives 4. Then take this side, you come up with this, and when you subtract, you come up with 4, -2. Therefore, A is 4 and B is -2. And that's how the 5 marks would be got. Then question 5 was from permutation and combinations. Actually, permutation because it dealt with arrangement. So it says, a man and his wife, Anne, have 3 children. Determine the number of ways the family can sit on a round circular table. So the keyword is circular table. If the parents must sit next to each other and part B not sit next to each other. So those are mutually exclusive. So we shall first put a round table where there is a man, wife, child 1, child 2, child 3. Here it means that when they are seated next to each other, these are taken as 1, but they can be rearranged to give you 2 factorial. And the overall will be 4 minus 1, which is 4 minus 1 factorial. Therefore, for part A, the number of ways will be this times this, which is 12 ways. Then for Roman 2 of part B, without restriction, the number of ways will be 5 minus 1. We are saying minus 1 because it is a circular table, to give you 24. Then the balance is when they are not next to each other, which will be equal to 12. And that's how we could get the 5 marks. Question 6 was from Newton's laws of motion, because I can see friction and also velocity. So it says a ball of mass 1 kilogram rolls from rest down a rough plane inclined at 30 degrees to the horizontal ground. The ball rolls for 4 meters before it reaches the ground. The coefficient of friction between the ball and the plane is 1/4. Find the velocity with which the ball reaches the ground. So one shall need to make a sketch of a force diagram. We have a ball and placed on a plane inclined at an angle of 30 degrees to the horizontal. The first force is the weight of the ball, which is 1g. 1 kilogram is 1g, where g is the acceleration due to gravity. Then its component parallel to the plane is 1g sine 30, and its component perpendicular to the plane is 1g cos 30. Then next force will be normal reaction, which is R. Then the direction of motion, because friction opposes motion, therefore after getting the direction of motion, friction will oppose. That is the first diagram. Next is to resolve parallel to the plane. So it will be this minus this equal to MA. So this is here, this is here, MA is here. Then substitute for G and for mu for R, which is G cos 30 degrees. So 1 times A is 1, is A. Then I can use a calculator to get the value of acceleration. Now that I know acceleration, I know initial velocity is 0, I know the displacement, I can get the final velocity at the bottom here. From the third equation of motion, substitute for U, for A, and for S to get the value of V. So that's how the 5 marks would come about. Question 7 is about, if you see 7 tosses, it means it's from binomial. So question 7 says, a coin is biased such that when it is tossed, the head is twice as likely to occur as the tail. The keyword here is twice. Okay. Find the probability that in 7 tosses there will be exactly 2 tails. So the word 7 tosses means it is now a binomial. So first get the probability of head and of a tail. So they told us probability of head is twice as likely to occur as a tail. So the ratio of the probabilities is 1 to 2. Implying that probability of tail is 1/3, probability of head is 2/3. So let x denote a random variable which is binomially distributed with n 7 trials and with probability of success 1/3. The probability of success comes from this statement that find the probability that in 7 tosses there will be exactly 2 tails. So the probability of getting a tail is the probability of success in this case. That is what we put here. So exactly 2 tails means x equal to 2. Now because this one is not there in the table, you have to use a formula. So 7 combination 2 times 1/3 squared times 2/3 to the power 5, which gives you this probability. So that's how the 5 marks would come about. Then question 8 is on center of gravity and says 3 particles of masses 2, 6, 10 kilograms are placed at points with coordinates this, and that respectively. Determine Roman 1 the coordinates of the center of mass from the origin, and Roman 2 the distance of the center of mass from the origin. So one, we have to take moments about the axes. We shall come up with this. Mass times this coordinate, this times this coordinate, this times this coordinate. Then this side it will be total mass times the overall center of gravity, center of mass. So we are using center of mass because they are kilograms. If they were newtons, it would be center of gravity. That's the only difference between the two, but the working remains the same. Then you simplify, where you can get now this in position in vector form, but they want coordinates, so you have to write it in coordinate form. That is part A. Part B, they want the distance or the center of mass from the origin. They want the magnitude of this position vector, which will be this. So that's how the 5 marks would come about. Now that was section A. Now we shall go to section B, which contains 8 questions and the student is supposed to answer any 5. Question 9 says, was from descriptive statistics or elementary statistics, and it says, the table below shows the age distribution of a population in a certain town in a census. Calculate the mean, variance, and also draw a histogram and use it to estimate the model age. Now in A-level principal math, it is rare to tell you to draw a histogram when the class widths are equal. So each time you see the word histogram, the first thing to do is to look at these class widths. Are they equal? If you look at this 10, 10, but this is 20. That is enough for you to know that they are unequal. Therefore, you have to use frequency density. And in this question, the first thing to do is to tabulate. Then you can start answering the question. So the age, you shall put there what was given. Now in this case, if you see the word under, it means there are inequalities, and inequalities means class is the same as class boundary. So what I've done, I've give this column contains both the class and the class boundary. Then we shall go to frequency. It was also given in the question. So you have to add all this together to frequency, which is 105. Then we need to get the mid-mark. Mid-mark is got by adding this plus this over 2. 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 Like that. So we don't need the total for the mid-mark, but we need to multiply. So because they ask for mean and variance, we need columns of fx and also fx squared. So let's start with fx. This times this, this times this, this times this, this times this, this with this, this with this, this with this. Then you have to add all these values and come up with this total. We also need a column of fx squared. So it means this times this squared, this times square of 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 this. Then you also have to add all these values to come up with this total. Then they ask for histogram, meaning we need to get frequency density. But you can't get frequency density before getting the class width. So let's just get a column of class width. Class width are got by subtraction. This minus this gives you that. This minus this. This minus this. this minus this, this minus this, this minus this, this minus this, like that. So now that I know how a column of class width and a column of frequency, I remember that frequency density is frequency over class width. So divide this, divide by this, this 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 divide by this. So now that you've finished tabulating, we can now start answering the questions. So here, you will realize that the question had the word thousands. Here, it had the word number in thousands, but the thousands was in frequency, so it wouldn't affect the final answer. So it is okay if a student added thousands here, 3 zeros here. And in that case, you'll get total frequency as this, fx as this, fx squared as that. So it is still okay. But the good thing is that it wouldn't alter the final answer, since it was on frequency. The answer will be altered if it was on x. So we shall go to part A, mean and variance. For mean, we need to get this and divide by this. So come and divide to get the mean they wanted. Then for variance, you need to code the formula. Then you substitute. Then you get the output. The next was histogram. Histogram, we shall need a graph paper or a grid paper. Then you draw the axis. I think you see how I'm leaving. Paper use, graph use. I'm leaving only 1 centimeter. Then I'll get the scale for the horizontal axis. And the scale goes from the classes or the class boundaries. I have to label the axis. Then do the same for the vertical axis. I have to label frequency density. Then I'll start. For the first class is that. Next class, so I'll come and draw a bar for the next class. Third class, 1.6. Fourth class, 1.8. Next, 0.8. Next, 0.3. And lastly, 0.2. So that is a histogram, but they also told you to use it to get the model edge. So look at the peak and then draw using a ruler those two lines. Then this intersection, draw perpendicular to meet the horizontal axis and read off that value. Then that will be the model edge. And that's how we could get the 5 marks from the graph. So now we shall go to question 10. Question 10 is from the topic of linear motion. So it says 2 points A and B are 526 meters apart along a straight road. A car moving along the road passes point A with a constant speed of 25 meters per second. The car maintains this speed for 10 seconds and then decelerates uniformly for 8 seconds until it attains a speed of v meters per second. The car maintains this speed until it passes point B. The total time taken by the car to move from point A to point B is 30 seconds. Part A. Sketch a velocity time graph for the motion of the car. Part B. Determine Roman 1 the value of v, Roman 2 the deceleration of the car. So here it means we need to sketch a velocity time graph. So you'll come here and draw the axes and label them horizontal and vertical. Okay, then here it said a car moving along the road from point A with constant speed of 25 meters per second for 10 seconds. So I'll come here and say that for 10 seconds the speed is constant. So I'll put here 10 and the speed which was constant was 25. Okay, then decelerates uniformly for 8 seconds until it attains a speed of v. So for 8 more seconds it decelerates. So 10 plus 8 gives you 18 here towards velocity of v. Okay, then proceed. The car maintains this speed until it passes point B. So maintains the speed, but they told us that the total time it uses here, they say total time taken by the car to move from A to B is 30 seconds. So the overall time must be 30. Meaning we shall put here 30, and here the time taken within that period was 12 seconds. So that is how you could get the 4 marks from part A. Then part B, the value of v. One, you shall remember that total distance is 526, so we have to get the area for this, which is the rectangle, area for this, which is the trapezium, area for this, which is the rectangle, add everything and equate to 526. So let's do that. This for rectangle, trapezium, rectangle, equal to 526. So we have only v as the only unknown. Meaning I can simplify and make v the subject. Then Roman 2, they want the deceleration of the car. So we shall use first equation of motion, substitute for v, u, and t to get a as negative this. So the negative means it was decelerating. Therefore, deceleration will be that. So here 1m was for this area, second area, third area, and equating to this. Then the output. So it would be okay if you put units, but ideally they shouldn't be units, because when they're specifying v, they put their units. So if you say v is 11 meters per second, it means you're going to get 11 meters per second. Then also again add these units, again meters per second, which is vec. Question 11 was from correlation and says, the table below shows the scores of 10 candidates in biology and economics. Part A, Roman 1, plot a scatter diagram for the data. Roman 2, draw a line of best fit for the scatter diagram. Roman 3, use your line of best fit to estimate the biology mark for a candidate who scored 57 in economics. Part B, calculate the rank correlation coefficient between the candidate's performance in the two subjects and comment on your result. So questions of correlation, the first thing to do is to tabulate. So you'll come and tabulate the students are those ones. Then the first mark, which was for biology, will be X, then for economics will be Y. So I'll come and put the marks for biology. And when I add everything here, the total will be this. I'm using the total, getting the total because they asked for a line of best fit. And line of best fit, we need to get the mean point. Then we go to the marks of economics. Then also add everything to get the total. Then from there, I'll start to rank. Ranking is done in descending order. So the highest is this, it gets rank 1, followed by this, it gets rank 2, followed by this, it gets rank 3, followed by this, it gets rank 4, followed by this, it gets rank 5, followed by this, it gets rank 6, followed by this, it gets rank 7, followed by this, it gets rank 8, followed by this, it gets rank 9, and lastly this, it gets rank 10. That is the rank for X. What about the rank for Y? To do the same, highest is 1, it gets rank 1, followed by this, it gets rank 2, followed by this, rank 3, rank 4, rank 5, then these are 2, there would be position would be 6 and 7, so get the average of the 2. So average of 6 and 7 is 6.5. The meaning here I'll put 6.5 and here 6.5. Then from 7 we go to 8, so this takes rank 8. Then these are also 2, one would be 9, another one would be 10. So average of 9 and 10 would be 9.5. So this 9.5, 9.5. So now that I'm done with the ranking, needs to get the deviation. This minus this. So this minus this, 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 this minus this. Then I'll square. When I square, I'll get this squared. So this squared, this squared, this squared, square this, square this, square this, square this, square this, square this, square this. Then you add all these values to come up with that. Then I also need the mean point somewhere. So average of the X values is that, average of the Y values is that. So the mean point will be that. So to help us when you're getting line of best fit. So far we have got 3 marks from this table. Now we can start answering the questions. Part A, Roman 1, plot a scatter diagram. There we shall need a graph paper. Then you draw the axes, horizontal and vertical. Then get a scale for the horizontal axis. And label it. Then also for the vertical axis, get a scale. And label it. The next is to start plotting. So 45 will correspond with 90, which is there. 63 with 64, which is here. 56 with 76, which is here. 61 with 70, which is there. 75 with 55. 83 with 53. 73 with 62. 50 with 85. 77 with 53. 70 with 62. So that is the scatter diagram they wanted. But they also told us to draw a line of best fit. Draw a line of best fit on the scatter diagram. So for the line of best fit, you have to also include the mean point, which is this. Then the line of best fit must pass through that mean point and any one or more points, leaving equal or either equal points on either side. So here there is 1, 2, 3, 4. So there are 4 points left on that side. 1, 2, 3, 4. And 4 points left. Okay, 5. So there are 5 points left on this side, which is okay because the difference is 1. Then we can estimate. The estimation was use your line of best fit to estimate the biology mark for a candidate who scored 57 in economics. So 57 in economics, you'll come here and look for 57. Take horizontal line to meet the line of best fit, then drop a perpendicular to meet the horizontal axis and read off that value. That will be 78. So I'll come and say the biology mark for a candidate who scored 57 is 78. That was part A. Then part B, they asked for calculate the rank correlation coefficient between the candidate's performance in the 2 subjects and comment on your result. So for rank correlation coefficient, we shall code the formula, substitute, and get the output. Then commenting, we shall compare with the table value. First of all, n is 10. So 10 compare with n of this. So the calculated value is bigger than this one, meaning it is significant. Also bigger than this, meaning it is significant. So we can come and comment significant at 5%, or we can comment significant at 1%. And that's how the marks would be got. Otherwise, this is not that, it should be 57. So now we shall go to question 12. Question 12 was from projectiles, and it says, a ball is projected from a point at the top of a cliff with a speed of u meters per second at an angle of 30 degrees to the horizon, 30 degrees above the horizontal. The greatest height reached above the horizontal plane through O is 0.9 meters. Find the speed u. Part B. Given that O is 60 meters above the surface of the sea, find Roman 1 the time taken for the ball to travel from O to the sea. Roman 2 the horizontal distance from the cliff to the point at the sea where the ball strikes. So 1, we are given the maximum height, so we remember that maximum height is given by this formula for projectiles. Therefore, come and substitute maximum height, then u is unknown, theta angle is known, g is known. So the only unknown is u, so I can make it the subject. And that is what they wanted. Then for part B, they wanted the time taken for the ball to travel from O to the sea and the horizontal distance from the cliff to the point where the ball strikes the sea. So there we need to make a sketch for you to understand, easily see what we're doing. So the cliff is 60 meters. Initial speed is 8.4 meters per second, and the angle is 30. So the ball will move and hit the sea at that point. So they want the distance from here up to here. Projectiles are in two motions. There's vertical motion and horizontal motion. So deal with each separately. Let's start with vertical motion. Vertical motion, we have that equation, then substitute for y, negative because the ball landed below the point of projection. Then u, theta, g. The only unknown is t, meaning I can solve it. So that is a quadratic which can be solved. Let's see the marks for this slide, then you can solve the quadratic. So this slide has 7 marks, then we shall go the next. We can either use both quadratic formula or factorization, but questions like this, it is advisable to always use the quadratic formula because most of the quadratics will not be factorizable. So if you look at this, it has decimals, meaning it was not factorizable. But t cannot be negative, so t is that. After getting t, I can get the horizontal distance by considering horizontal motion. X is ut cos theta. Substitute for u, for t, and for theta to get that. And that's how we could get the remaining 5 marks. Question 13 was from probability theory still. It says part A, a woman traveling to work by a car goes through 3 police checkpoints A, B, and C. The probabilities that she is delayed at A, at B, and at C are these respectively. Determine the probability that she is delayed at only 1 checkpoint, and Roman 2, 2 or more checkpoints. So let's start with part A. So only 1 checkpoint is she can be laid at only A, or at only B, or at only C. The O is what caters for these additions. Then we can substitute this for this, this for this, and this for that. Then use a calculator to come up with the answer. Then 2 or more, here 2, that is B and C, here it is B, A and C, A and B, or more means also 3, A, B, C. Then you substitute for each, this for this, this for this, this for this, this for that. Then you can use a calculator to get the answer. Alternatively, you could remember that 2 or more means 1 minus none or 1. To make it just shorter, because you already have only 1, so just get for none, then substitute and get the answer. Any of the 2 is okay. So that's how we could get the 6 marks for part A. This is A Roman 1, A Roman 2. Now shall go to part B. Part B says a man goes to work by route P or route Q. The probability that he takes route P is 0.6. The probability that he is late, given that he goes through P, is 2 over 3, and through Q is 1 over 3. Roman 1. Find the probability that he is late for work on a certain day. Roman 2. Given that he is not late, determine the probability that he went through P. So here it is easily done with a tree diagram because there is a condition. I think you saw that word given. So shall come and draw our tree diagram. Then shall start for P 0.6, meaning the complement is 0.4. Then let given P is that, the meaning the complement is that. Let given Q is this, meaning the complement is that. Then we can get the probability that is late. So it can be L intersection P, so P intersection L, or Q intersection L. In other words, late is here and here, which is this times this, or this times that, which gives you this as the answer. Then Roman 2, P given L complement. Expand this to give you that. Then this is P and this, which is this. Then this one down is the complement of this, so it becomes 1 minus that. Use the calculator, will come up with 3 over 7. And that's what they wanted. So that's how we could get the remaining 6 marks. Question 14. 3 forces, this, and that, act at points, these ones. Determine, part A, the magnitude of their resultant force. Part B, the equation of the line of action of the resultant force. Part C, the distance from the origin at which the resultant cuts the x-axis. And part D, the force that should be added to form a couple. So let's start with part A. Resultant force is got by adding all the 3 forces. So when I add, I'll come up with this, but they want magnitude, which will be that. That was part A. Part B, they want the equation of the line of action of the resultant. So we are going to take moments. Sum of moments is equal to moment of resultant. So sum of all moments are these ones. This for the first force, second force, third force. Then it's the one for the resultant. We are using xy because we don't know where it's acting from. So the determinant, this minus this gives you this. this minus this gives this, this minus this gives this, this minus this gives that. Then you simplify and rearrange to get the equation of the line of action. So that's how we could get the 8 marks. Then for part C, they want the distance from the origin at which the resultant cuts the x-axis. In other words, they want the x-intercept. And for the x-intercept, y is equal to 0. So we shall come and say that when y is equal to 0, x can be equal to that, and that will be the required distance. Then for part D, they want the force that should be added to form a couple, meaning the resultant should now be 0. And that force will be just the reverse of the resultant. That's why you put a negative of the resultant. And that's what they wanted. Question 15 was from cumulative distribution functions. It says a continuous random variable x has a cumulative distribution function given by this. Find the median, the PDF, and the probability, and the mean. So let's start with the median. Here you have to test. For example, when I put 0 here, I get 1 over 6, which is smaller than 0.5. But when I put 2 here, I get 5 over 6, which is bigger than 0.5, meaning median lies along that interval. So I'll come as that F2 is that, meaning that median, I've got where the median lies, so I can now get the median. Fm will now be this, equal to 0.5, and make m the subject, meaning median is 1. Part B, they wanted the PDF. To convert from capital F to small f, we have to differentiate. So I'll differentiate each function. For that, differentiate, I get 1 over 6. Differentiate this, I get 1 over 3. Differentiate this, I get a quarter. Differentiate this, I get 0. Then I can rewrite it with 0 elsewhere. So that's how we could get the 6 marks in part A and part B. Then part C, they want this probability, and lastly the mean. So this probability, if you look at it, this one is in this interval, and the 2.5 is in this interval. So for 2.5 we shall use this expression, and for F1 we shall use this expression. Then we subtract the 2. So substitute and get the answer. Then the mean, you have to get fx. So probability times x, probability times x, probability times x. Then you integrate and you substitute limits and get the output. And that's what they wanted. Then question 16, the diagram below shows a uniform rod 8B of weight 10 newtons hinged to a vertical wall at A. The rod is held in a horizontal position by means of a light inextensible string. One end of the string is attached to a point C on the rod, and the other end is attached to a point D on the wall. The point D is 0.6 meters vertically above A. and the length of SC is 0.8 meters. A particle X of weight 25 newtons is attached to the rod at B, and the tension in the string is 75. Part A, find the length of the rod at B. Part B, calculate the magnitude and direction of the reaction at the hinge. So the first thing to do is to complete the force diagram by showing all the forces acting on the rod. So let's first redraw the given diagram. Then we can show the forces. One is for that weight there. The length of the rod, we don't know it, so it will be D. Then next is for the weight, which is the center, so it will be half of D. Then the tensions, arrows must point towards each other. Then the reaction at the hinge, we have split it into two, X and Y. So we need to get this angle for us to easily resolve and take moments. The good thing, we know this distance and this distance, so we can get that angle. So tan theta is equal to this, implying that sin theta can be that and cos that, or you can just simply get the angle. Then we shall take moments at A. When I take moments at A, this has 0 moment and this has 0 moment. Remember, the formula for moment is F d sine theta. Okay, so for 75, this is the force. The distance is from here up to here, which is 0.8, and the angle is this, which is 36.87. Or can say sine theta is the whole of this. So force times distance sine theta. Then for the other one, for this one, already it is 90, so it will just be force times distance. For 25, already this is 90, so it will just be force times distance. D is the only unknown because I already know sine theta, so I can make D the subject, and that will be the answer they wanted. Then part B, they wanted magnitude and direction of the reaction at the hinge. So we need to get resolve and also take moments. When I resolve horizontally, I'll come up with x being equal to 75 cos theta, which gives you 60. Then vertically, y plus this is that, which gives you that, cosine theta is that, then y can be equal to that. We need to get the magnitude and direction. So we are going to draw our right angle triangle, positive horizontal and negative vertical. Get the magnitude, then also get the direction, this beta. Therefore, the magnitude is this and the direction is south, that east. So that is how the 8 marks would be awarded. And that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on marking guide for Senior 5 Sub-Math, end of term 3. So if you are not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.